Welcome to Prajim Technologies. This is Venkat. In this part, we will look at the common operators in C Sharp. Just like any other programming language, even C Sharp has some common operators. Okay, and we can actually classify these operators into assignment, arithmetic, comparison, conditional, ternary, and null coalescing operators. So assignment operators in C Sharp is equal to, and similarly we have several arithmetic operators like plus, minus, etc. Let's look at a simple examples on how to use these operators. So we have a simple program here. For example, if I create a variable of type integer, int I, and if I want to initialize this to a value of 10, I can use the assignment operator equals. So just like C or C++, you use equal to assign a value to a variable of any type. It could be integer, boolean, whatever. For example, if it's boolean, I will say boolean b equal to true or false, whatever is the value that you want to initialize that variable to. So that's about the assignment operator. Single equals is the assignment operator in C Sharp. Um, Whereas we have several arithmetic operators like plus, minus, into, and as the name suggests, they do the respective operation. For example, if you want to add two numbers, you use the plus sign, and similarly for subtraction, you can use minus, etc. There are these two operators. If you have two numbers to divide, and when you divide two numbers, you get two results. One is the quotient and the other one is the remainder. Okay, so if I divide number 10 by 2, I get the quotient as 5 and the remainder as 0. Okay, so depending on which operator you use, either forward slash, if you use forward slash, you get the quotient, which is 5 in our example. If you use percentage, you get the remainder, which is 0 in our case. So let's do a quick demo on that. So for example, if I have int numerator, and let's set that to, let's say, 10, and we want to add denominator, and let's set that to maybe 2, denominator 2, int result equals numerator, and look at this, I am using the forward slash numerator by denominator, and forward slash will give us the quotient and not the remainder. So if I print this result out, console.writeLine, and let's use the placeholder syntax to print that. So result, so we want to just say result equals result. Okay, so now if we go ahead and run this, we know if we divide 10 by 2, we get the quotient as 5. So if you want quotient, use the forward slash. On the other hand, if you want remainder, use percentage. So this will give us the remainder. So 10 divided by 2 is 0, so we get the remainder. So simple arithmetic operators, just like any other programming language: plus, minus, into, forward slash for quotient, modulus or percentage for the remainder. And comparison operators, we have already seen single equal to is the assignment operator, but whereas if you want to compare two numbers, then you have to use double equals. For example, let's say I have, maybe we are initializing, we'll call this as number instead of numerator, just to give it a meaningful name. So int number is equal to 10. Now if I have to compare, or if I have to check in my program if the number is 10, I can't say if number equal to 10. You can't do that because a single equals in C# have a meaning. It's basically used for the assignment operation and not for comparison. If you want to really compare, then you have to use double equals. Okay, so if you are using double equals, you are using that operator for comparison. Okay, I am checking here is the value of number 10. Okay, on the other hand, if you want to check for not equal, then you use an exclamation if number not equal to 10. Okay, and this expression obviously returns a true or false if the number is 10. In this case, it will actually return false because number is equal to 10. So if you want to check for not equal to, we use this one. If you want to check for equal to, we use double equal. Similarly, we have greater than, equal to, less than, and less than or equal to. Again, this is very much similar to any other programming language like C or C++ and Java. And the other most important operators that we have in C# are the conditional operators, the and or. Okay, so basically, if I have to, check two conditions, then I can use the AND operator. If one of the conditions is satisfied, if that's enough, then I can use the OR operator. Let's look at an example for this. Let's say I have number I and I have another number. Maybe that's, let's say, set to 20. Okay. Now, if I want the number to be 10 and another number to be 20, and only then will I have to do something, then I can say if number is equal to 10 and another number is equal to 20. So in this case, both the conditions should be satisfied. Otherwise, whatever code that you have here will not be executed. Console.writeLine. Okay, so hello. Now, since number is 10 and another number is 20, this hello will be printed, but otherwise it won't. Even if one of the numbers, if we set, let's say, for example, another number to 21, so obviously another number is not equal to 20, so this condition is not satisfied, so it will not print this one. So if we go ahead and run this, it doesn't print hello there because this condition is not satisfied. But on the other hand, if you use the OR operator is the pipe symbol. So if I use OR operator, if any of these conditions are satisfied, then this piece of code will be executed. Okay, so in this case, number is equal to 10 is satisfied. That's true. So it doesn't even, the compiler doesn't even, the runtime environment doesn't even bother to check this condition because this is already true. And if one of the conditions is satisfied, it can execute this code. So if we go ahead and run this now, so the hello world is printed. Okay, so conditional and conditional or. If it is conditional and, all the conditions should be satisfied to enter that block of code. Otherwise, if it's or, one of the conditions, if one of the conditions is satisfied, then it's more than enough. Alright, the next operator that we talk about is the ternary operator, which is, kind of actually very interesting operator. So let's take a simple example to understand ternary operator. Let's say I have this variable called number, which is equal to 10. Now what I want to do is I want another variable, maybe Boolean variable, is number equal to 10, or let's say simply is number 10. I have a Boolean variable here. Now, if, sorry about that, if number is equal to 10, then I want to set this variable is number 10 equal to true. Else, I want to set that variable to false because it's not equal to 10. So if you look at here, we are using the comparison operator, we are using the assignment operator, and finally, what I want to do is console.writeLine number is equal to 10 is whatever, true or false. And who will let us know that? The variable is number 10. Okay, so if you look at this program, it's a very simple program. Int, we have declared an integer variable of type with a value of 10, and we are checking if that number is 10, we are assigning this boolean variable to true, otherwise false. And then we are saying number is equal to 10 is, into this placeholder we will substitute this one. If it's true, true, otherwise false. So now here number is 10, so if we go ahead and run, okay, number is equal to 10 is true. But on the other hand, if we change the value maybe to 15, number is not equal to 10, so number equal to 10 is false. Now look at this, just to check if this number is 10 or not, and initialize this variable with true or false, we are having so many lines of code. But if you actually use a ternary operator, all this can be done in just one line. So if you look at this, 1, 2, 3, 4, 5 lines of code can actually be replaced by one line if you know how to use ternary operator. So let's see how to use this ternary operator. So bool is number equal to, if number is equal to 10, then return true, else return false. It's actually as simple as that. Now you can get rid of all these lines. So if you look at this, it's a 3-line program right now. Okay, so what we are doing is basically we are declaring a variable of type is number 10, of type boolean, you know, and this variable value should be equal to, if this expression is true, then return true. If this expression is not true, then return false. Okay, whatever follows question mark is the true part, and whatever follows the colon part is the false part, and that value will be stored here. Now if I go ahead and run, the output of the program will be exactly similar, except that we are using the ternary operator here. So that's the ternary operator. Null coalescing operator, we will talk about this in a later session when we actually talk about nullable data types in C#. Okay, so we need to understand nullable data types, and then we will talk about null coalescing operator. And we have seen this example in a demo, without ternary operator we have to have so many lines of code, but with ternary operator the program size is relatively much smaller. That's it for today. If you want more resources, you can visit PrajimTech at prajimtech.com, and for ASP.NET C# and video tutorials, you can visit these respective resources. Thank you for watching. Have a great day. Hello, welcome to Prajim Technologies. I am Venkat. This is part 6, Nullable Types in C#. In this session, we will learn nullable types in C# and about null coalescing operator. Now, actually in C# we can broadly divide the types into two categories: value types and reference types. In our previous module, we have already seen value types, the built-in value types like integer, double, float, decimal, etc. Okay, and we also have, apart from these built-in value types, we also have reference types. We have seen one of the built-in reference type, which is string. String is actually a class. Okay, and examples of reference types include classes, interface, delegates, arrays, etc. We will talk about the differences between value types and reference types in detail in a later session. Okay, at this point what we need to understand is that in C#, the types can be divided into two broad categories: value types and reference types. Examples of value types: int, float, double, etc. Examples for value types: classes, interface, delegates, etc. And another point that we need to keep in mind at this point is the default value for reference types is null, whereas the default value for value types is some form of 0. For example, if it's an integer, the default value for any variable of type integer is 0, and they cannot hold null values. Let's actually look at a demo. So for example, I told you string, which is a class, is actually a reference type. So for example, when I say string name equals null, and then if we try to compile this, it will compile without any problem because reference types can have null values. But whereas if I create a value type, for example, integer is a value type, so int I equal to null, and if we try to look at this, we already have got the red squiggly cannot convert null to an int because it's a non-nullable value type. So I is a value type and you cannot initialize that to a null value. Okay, but whereas reference types can have null values. So that's one important difference at this point between value types and reference types. There are several other major differences between these two, which we will be talking about in a later session. Okay, now if I have to store a null value in a value type, how do I do that? Is that at all possible in C Sharp? Absolutely. In C Sharp, the value types can be actually divided into two types again, non-nullable value types and nullable value types. So if we go back to the presentation, so by default, value types are non-nullable. To make them nullable, use question mark. So let me give you an example for that. So here I is a non-nullable integer data type. Now if I have to make this nullable, all I have to do is use a question mark. And now look at that, that red squiggly goes away, which means if you want to make a value type nullable, just put a question mark next to the type. That makes it nullable data type. And why did C Sharp introduce this? There are actually several reasons. One of the reasons is, let's say for example, you have a form like this, where a user has to supply his first name, last name, which are mandatory. But whereas are you a major, this field is optional. And if the options for this are yes and no. Okay. And if the as this field is optional, he might choose not to answer. If he says, if he didn't answer, are you a major? Then how will you store that value? So let's say, for example, we have a Boolean flag here. Boolean, are you major in the application? Now, this can only be true or false because look at this. Are you a major is we don't have a question mark, meaning it's a non-nullable value type. Okay, so if it's a non-nullable value type and a Boolean value can only take true or false, but here if the user doesn't select yes or no, it means he didn't select any answer for this field and this field is optional. So what value will you initialize this field with? Is it true or false? If you initialize that with false, it's as if the user has said no. Okay, so we should be in a position to store null values in this variable of type Boolean because are you a major? Yes, no, the user did not answer. There are three options actually. If the user didn't answer, it means he did not select any of the yes or no options for this question. So if he didn't select any of the options, then I should be capable of storing null value. Otherwise, we will not be in a position to differentiate between the user not answering the question and saying no if we store this value as false. That's why these nullable types are so much useful. And another reason why these nullable types are so useful is because databases does not have the concept of value types or reference types. Whether if it is nvar, integer, whatever is the data type, you can store null in the column of a table in a database for any data type. Okay, but value types and reference types are only C# concepts. Okay, so when it comes to working with C# and databases, we have to have some form of transformation between nulls and non-null value types. But with these nullable value types now, we don't have to do that conversion anymore. Now it makes working with database fields very much easy. So these are some of the reasons why these nullable data types are very helpful in C#. So let's complete this example. So I can make this boolean are you major null. So within this form, if the user does not select yes or no options, then this field will be null anyways. Okay, and let's say for example we want to check if are you major is equal to true. We can say console.writeLine, maybe user is major. You can either say are you major is equal to true, or you can simply say are you major dot value. From the IntelliSense, if you look at this value actually returns a boolean data type, not a nullable boolean data type. Okay, so you can say if it has to be false. So you can either say if this is true, user is major. If not true, user is not major. So you can either say it this way, or you can say it if are you major is equal to false. Either of them will work. And else, okay, keep in mind a nullable boolean data type can hold three different values: true, false, or null. If it is true, we are saying user is major. If it is false, user is not major. If it's not true and if it's not false, the only other option that's available, it could be null. So we can just say console.writeLine, user did not answer the question. Okay, so now we are in a position, if the user didn't answer the question here, yes or no, he didn't select any of these options, then IU major will be null and will be in a position to say user did not answer the question. But in case if we didn't have this boolean flag, we may have to initialize the to false. So in that case, we would not have been in a position to differentiate between the user didn't answer the question or he's not a major. So now if we go ahead and run, since IU major is null, we get that user did not answer the question. Okay, a little grammatical mistake there. All right. On the other hand, if he says true, then obviously user is major. Okay, so that's about nullable types. Even the integer types, you can make them nullable. Okay, all value types, they have the respective counterpart nullable types. Another concept that we'll talk about is the null coalescing operator, which is really interesting. Now let's say, for example, I have a field called number of tickets on sale equal to, let's say, 10. Okay, I have tickets on sale, and I have another variable, let's call available tickets. Let's say this tickets on sale is a nullable data type, and there are no tickets on sale right now, so which means tickets on sale is null. So if tickets on sale is null, then obviously there are no tickets available. So if tickets on sale is equal to null, then we know available tickets, we want to initialize that to 0. Else, let's close this brace. else available tickets equals whatever are the tickets that are on sale. And finally, let's print how many tickets are available. So we can say available tickets equals available tickets. Now look at this. We've got an error here. It's saying, okay, I cannot implicitly convert type int question mark to int, meaning there is no implicit conversion between a non-nullable type and a nullable type. Okay, we have to be explicit about the conversion. And one way to do that is simply say dot value. Dot value, if you look at the IntelliSense, it returns a non-nullable counterpart, an int. You look at that, int without a question mark. So that's one way to do that. Or you can use the cast operator. We will talk about implicit and explicit conversion in another session in detail. So you can either use this conversion. Okay, what we are doing is, okay, this is a non-nullable type. If you look at this tickets on sale, it's a nullable data type, but an int without a question mark is a non-nullable data type. So we are forcing non-nullable data type to be converted, nullable data type to be converted into non-nullable data type and assigning it to this variable. Okay, so if I go ahead and run this, obviously since tickets on sale is null, available tickets will be 0. But on the other hand, if you initialize that to some number, maybe 100 tickets on sale, obviously available tickets will be 100. So what's going to happen here? It will check, okay, tickets on sale, is tickets on sale null? No, it is equal to 100. So it comes to the else block. Okay, tickets on sale, value is 100. It will convert that to non-nullable data type integer and stores it in this variable. And finally, we print that out. Okay, now look at this. If it is null, is 0. Instead of null, we are initializing that to a default value because this cannot hold null, this variable, because it's a non-nullable integer data type. Okay, now do we have to have so many lines just to do that? If it is not null, use the value that is present and available in tickets on sale. Otherwise, use some default value. So do we really need to have these many lines of code just to do that simple thing? No, not really. That's why we have this null coalescing operator, which we can make use of. And the way we do that is pretty simple. You can get rid of all these lines and you can simply say int available tickets is equal to tickets on sale question mark, that's your null coalescing operator, and whatever is the default value that you want to initialize this variable with in case if this nullable data type is null. Okay, so what this line is doing, it's pretty simple. If tickets on sale is null, then use this default value. Otherwise, use the value that is present inside this variable. It's as simple as that. So it's just one line. So if you go ahead and run, the behavior will be the same, except that instead of using if and else, we are using the null coalescing operator, which is very simple to use. So this is without null coalescing operator, and this is with null coalescing operator. So you can see the difference, the number of lines has been reduced. So that's it. Thank you for watching. For more resources, you can refer to these things on the slide. Have a good day. Bye bye.